that first job, they kind of just threw me into it. And I was back there breaking, tips and all sorts of stuff, drill bits, trying to make things. And I actually helped build part of a starter generator motor for a crop duster plane, like the outer housing. And um, definitely a very memorable experience of just working with an older engineer and then learning early on it's okay to break things and have that experience firsthand.
Hello and welcome to the Being an Engineer podcast. Today we're speaking with Szymeczek, a mechanical engineer with 15 years of experience across aerospace, oil and gas, consumer products, and medical devices. He currently serves as new product development lab manager for Tech Help Studio Blue and is an adjunct professor in mechanical and biomedical engineering at Boise State University. Stephen's expertise spans product development, design engineering, and design for additive manufacturing. He is also board president of 3D Printing Mentality, a nonprofit focused on developing the next generation of additive manufacturing professionals. Stephen, thanks so much for being with us on the show today.
Thanks, Aaron. Yeah, happy to be here. Happy to dive in, and thanks for the invite.
Absolutely, yeah. So
Yeah.
you and I, we connected kind of a long time ago. I can't remember exactly how long ago it was, but I don't know, 10 or even 15 years ago or something like that, right?
Yeah, so definitely a decade I think has passed, which is it's sad to say, but yeah, time flies, and yeah, it's been a fun last 10 years. A
Yeah,
lot changes, a lot happened. COVID happened, so
right.
yeah.
Yeah. Well, let's start with the question I ask everyone in the beginning. What made you decide to become an engineer?
So I think yeah, when I was younger, I had an interest in airplanes and aircraft was kind of a first one. So the idea of flying was appealing to me all the way from when I was pretty young. So I wanted to be something like a pilot. I thought about maybe joining the Air Force, but it kind of turned into this mix of I just loved how things worked and I loved taking things apart. So I was one of those kids over at my grandma's house, and I'd be in a corner and she'd find me taking something apart, just curious how it worked. And so the combination of that, and then I had a couple of friends who I went to high school with who were also looking, what were they going to do with college? And engineering kind of seemed like that good fit. Mechanical engineering being a little bit more broad too, seemed like a great fit if I wanted to do something aerospace or if I wanted to kind of pivot. But yeah, that was kind of the introduction, and the curiosity was just wanted to know how things worked, and so that's kind of where it started.
When you were a kid taking things apart, do you remember anything in particular that you had a really fun time taking apart or
Oh
putting
yeah.
back together?
So I think it was one of the earlier on wind up flashlights. So I think I was
Oh,
just yeah,
yeah.
I was always curious about changing at the time, kind of understanding a little bit of like one form of energy into another.
Ah,
Like I just fascinated by it's like, man, you can crank this and then it can generate light. So I remember taking that thing apart and trying to figure out how to work. Pretty sure I didn't put it back together correctly and I ended up getting another one. But yeah, just that curiosity of how can you take something at that time like mechanical energy, change it into to light output and light energy. So yeah,
yeah.
that kind of curiosity was blended. Then of course, yeah, small aircraft. Like I started slowly getting into RC aircraft, and I can, it went through college too. I did SA Aero Design was my capstone for college. So yeah, loved loved smaller things like RC aircraft, small devices, and then yeah, the curiosity built originally from there.
I remember when I was a kid, I was probably 10 years old or something. I had this little FM radio, right? Just like this crummy little FM radio with the plug you stick in for the headphones. And I took it apart, took the back off. There was still a battery in it. It was still powered, but I just took the back off to see what it looked like on the inside. I was curious, and it was a PCB in there at that time. I didn't even know what a PCB was really, but I thought, oh, this is so cool, right? How neat. And I took the jack, the headphone jack, and instead of putting it into the standard receptacle, I just started touching it on like different points on this PCB, and at some point I touched just the right contacts, I guess, and I was able to hear the music through whatever I had touched. And man, for some reason I thought that was just the coolest thing, like putting this jack on a different place and somehow picking up sound still. That was probably one of my early experiences with quote unquote engineering that got me interested in it. Of course,
Yeah.
these days I know nothing about electronics, and my team won't let me near them for good reason. But
Yeah, no, that's great. Yeah, that fascination of just how does that work? How can I figure out how this works? And yeah, building on that and always keeping that curiosity and lifelong learning kind of from the beginning, right?
yeah,
Yeah.
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 So you've done a lot in engineering, oil and gas, and biomedical and mechanical and aerospace. What have been some of your favorite places to work or your favorite projects?
Oh man. Yeah, so I've definitely worked a lot of different places. Like I did go into aerospace the first part of my career. Like I mentioned, I did SAE Aero Design when I was at Northern Arizona University, where I graduated from in mechanical engineering. And I did get a job at first with a small crop duster plane company based out of Flagstaff, Arizona. It was one of the first jobs that I had. I interned there for a while, actually, as a technician. So I was actually building crop duster plane parts as part of when I was working there part time until I graduated, and then they made me into an engineer, and that was my first big boy job. And it was definitely a great experience to be able to get hands on in something. So I'm not going to say anything against my university, but the hands on skills early on, being able to work like a lathe and a mill and be able to think about how something is designed, but then how it's made and manufactured was kind of that first connection point where I realized I might have lacked a little bit in college. And then that first job, they kind of just threw me into it. And I was back there breaking, tips and all sorts of stuff, drill bits, trying to make things. And I actually helped build part of a starter generator motor for a crop duster plane, like the outer housing. And definitely a very memorable experience of just working with an older engineer and then learning early on it's okay to break things and have that experience firsthand, and really not being afraid to jump in something that might seem overwhelming. And that was kind of, yeah, my first job. So yeah, that starter generator motor. And even since then, I don't think I've myself made something without working with another team. Since that point, when I very first, because there wasn't a lot of people at this company, so it's like a 25 person company, so you did everything. You worked on the line, you manufactured your own parts. If you were an engineer, you designed and did your own analysis. They just kind of did everything. So that was definitely a big first project that I worked on. Was helping build that starter generator motor, and then kind of from there, I left there and I joined BE Aerospace at the time, doing aircraft interiors. So I thought I wanted to work for Boeing, Airbus, or someone doing commercial aircraft. I wanted to be more on the big structure side, but I kind of got forced into doing seating and interiors design, which was still fascinating. But I think over that time, I kind of started creating this. I didn't really want to be corporate mentality. It kind of started in college a little bit. I had an inkling of maybe wanting to go out and start my own business with a friend from college. And when I was in corporate, it was great. I got to be, in a larger company doing design engineering, working with the team. But there was kind of this desire to want to kind of branch out, do more than just aircraft interiors. I discovered 3D printing shortly after college too. I didn't even really know what it was in college, and I think it was the year after that I discovered it. But I knew I wanted to do something with 3D printing, so that's kind of leaning into later projects. And
What do you
I
think that desire to not be part of the corporate engine, maybe go out and start something on your own? Where did that come from? Like, is your family entrepreneurial history there, or was that just completely out of left field?
so my friend that I had in college that we were pretty close. His dad had done some consulting, kind of as a side business. So he was around that growing up, and my dad also not being an engineer, and like he was a supervisor for the parks department, and almost became a mechanic. So that's a little bit of that background side, and he did some side work. But I think more so, it was one of those, the options of not doing a corporate job and talking through that with friends from college, and particularly my one friend who had his dad who did consulting, um, kind of knew a little bit how that worked, setting up your own business, and started realizing it might not be as hard. So I think it started there, and then I just really liked the creative part of being able to start my own thing. I think that was part of it. Engineering's very, I want to call it concrete, but you're kind of forced down, first principles, everything makes sense. Where business, it's kind of that same way, but you can kind of put your own self and your own drive into something a little bit different than you can do with a corporate job. So,
How did it go for you when you started your first business? Like what
yep.
were some things that you just didn't know you didn't know?
Yeah, so I was working aircraft interiors. I started a side business basically. So I started an LLC, um, and really I had no business training, like no background. I took one business class in college. So basically, I just told myself I was just going to go to events and just kind of learn. So this was in Tucson, Arizona, where I started this business, and I went to Startup Tucson, all of these events, and basically just started meeting people. And oh boy, did I realize just the dynamics of being an engineer and that whole other side of business that goes with being able to talk with somebody, learn what their needs are, and learn how to satisfy those needs with something that you can offer. So that was a big learning curve, and I think also connecting with folks in the area that had already been 15 plus years in business, and just getting that mentorship initially too was pretty big. But I think in the beginning, I took anybody who wanted to be a customer. It was um, anywhere from somebody that had a couple $100s to somebody that maybe had a couple $1,000 and could had a little bit more development budget. But I basically had CAD skills, and then I had 3D printing technology that I got introduced to. I could go down to hackerspace, makerspace, and print off prototypes fairly rapidly. And so, but all those dynamics of just working with people, I think I had to learn, just kind of by trial and error, and definitely making mistakes too in the beginning of where you make promises or you say something in a certain way to somebody, and then when they see it physically, there's a disconnect. And so learning over time to be able to bridge that gap between the expectation to physically what you can produce for them. So
Yeah. Do you
yeah.
remember one of your first customers and how you felt when like, oh, I did it. I got a customer, someone who's actually willing to pay me money to do
Yes.
engineering work.
Yeah, there's a couple of fun first ones, and then one earlier on that came back later too. And I didn't. They wouldn't even tell me what it was at first. So it was a plastic component that was structural, and basically was to help assist hold somebody up, but they wouldn't tell me what exactly it was. So it was an assistive device. And then eventually I started asking more questions. They divulged a little more information, and it actually turned out it was a potty booster. And they wanted to injection mold it, and then they wanted to make a whole bunch. And so this was a fun, just first project. I'd done a little bit of injection molding, design for injection molding, but I got to 3D print prototype a couple different iterations, and then really started working with them on, why they were doing it. It's like, oh, why would you, even make this in the first place? But they were to make it in one monolithic piece, slide underneath any standard toilet seat, and then basically make it really easy to install non-slip pads. And they did. They had like a small market of people that were interested. They got momentum, and then I was able to help iterate through the injection molding design with them. Work with a tooling company actually based out of Phoenix, and then they got to a point too where, yeah, they paid me money. I was excited. It wasn't a whole lot of money in the beginning because I just wanted to have customers. I wanted to have use cases. Um, and then they kind of just disappeared all of a sudden. And I think I realized after that, that's a lot of customers, is that these individual entrepreneurs, they come with you, they have great ideas, but you can run out of money really fast.
Yeah.
So that was, from both sides, it was an exciting project to be a part of. And then funny enough, it reappeared almost a decade later, and it was on Shark Tank. And so,
No way.
yeah. So they ended up getting funding later from Lori, I think, one of the sharks. And yeah, super training potty booster, basically, product. And it's out there now. It's being sold in big box stores.
That's awesome.
So, but yeah, that was one of the early on, not really being kind of shy, not asking a lot of questions, finally realizing what it was, and then starting to realize that most of a good chunk of the work wasn't me just doing a design. It was trying to relay what they were trying to get across in the actual use case and the product, and connecting all the dots together. So.
What were one or two of the most important lessons that you learned early on with your own business, having the engineering background, but not necessarily the business background? You mentioned like asking why, right? Why are you making this? That's a good one. Any other pivotal lessons that you learned early on during those days?
Oh, I think the 3D printing technology was early enough, and I love the fact that I could make things quickly and rapidly. But even in those early days, not promising too much with the early 3D printing technology because everything seemed to break. You were always working on your printer, and so you were spending a whole bunch of time just trying to fabricate, a part for them while also doing design, also doing the other work. So eventually, I would say, when you're looking at doing that kind of service where you're designing and creating and prototyping something, going out and creating a partner network where you can actually manufacture, have design for manufacturing feedback, work with somebody directly. So I started formulating 3D printing partners after I made some of those first mistakes of, I could do all this by myself. I could work with a hackerspace. I could have my own printer, but is it worth my time and effort? And could I have more clients? Could I build out in a better way if I were able to work with somebody who had access to, say, like a print farm? They made parts at a larger scale. And so that's what I would say. When you're starting out, look at what you can build out your network with, and trusted partners that you can kind of build up your services with. So.
Yeah. I remember in the early days of Pipeline, back when it was just me, and frankly, even beyond the early days, but there have been times, thankfully not many times, but on occasion, there are times when I lose money, right, doing something. And I wonder, were there any experiences, I'm going to make an assumption here, that you had similar occasions every now and then where you had to lose a little bit of money somewhere? Was there anything you can remember where you felt like it is worth doing this and losing money on this thing because of whatever the reason was? But any experiences like that?
Yeah, I think as I started branching out into other industries, and I think I had a medical device customer. It was one of the earlier on, like, first medical device customers. And I think I wanted to have a medical device customer so badly that I undercut myself, and quite significantly, on the quote that I gave. And yes, getting that customer was great. Having that use case was great. But definitely undercutting yourself can be bad, because I think I lost out on a lot of money, not just on that project, because I overextended myself. I wasn't able to get other projects in. And as I started building out that client base, and eventually I left corporate and I started doing this full time. Fun stories all there I can get into, but I would say budgeting your time across projects, right? Even if something seems great, if you undercut yourself too much somewhere, it's going to come back and bite you one way or another. And so, yeah, even if it's a great use case and you have to build those, you have to build that up. But definitely giving yourself credit. And it is hard. It's hard to go out and increase your rate or say that you're more valuable if you haven't been around a long time. But I would say, yeah, undercutting yourself for the sake of getting somebody in and then it biting me has probably come up more than just that one time. But yeah, that's
It's tricky, right? It's not a black and white question where it's very clear when it makes sense to do something like that or it doesn't make sense to do something like that. I know several years ago, there was a customer that we really wanted to get our foot in the door with, and they gave us an opportunity to quote something, and we did. And apparently it was way too high. They said, no, this is like way beyond what we're willing to pay. But the process of quoting with you guys went really well. We enjoyed your communication. The concept that you gave us made a lot of sense. We really liked all of that. We just didn't like the price. So we had this other opportunity, and if you're willing to quote this one, we'd love to find a project to actually work with you guys on. And they were pretty good about it. They told us up front, your price needs to come in, at X for it to make sense for us to move forward. And it was a pretty big project too. Automation project, and so we internally discussed, all right, what is it actually going to cost us to do this thing, and can we meet their price point? And I think our initial quote before we gave it to them was it was probably 25%, 30% higher than what they told us. It has to be this number. So we asked ourselves, is it worth undercutting ourselves, basically, right? Giving them a pretty steep discount in order to get our foot in the door. Is it going to pay off later on? And we just didn't know, right? We hoped it would, but we didn't know. So we kind of took a leap of faith and thought, all right, let's just give it a shot and see what happens. We didn't think that we were going to lose money on it, but we also knew that we weren't going to make any money on it. And so we went forward and met their price, and they gave us a PO when we did the project, and it went really well. And then they actually came back later and said, hey, this was great. We need a second one of this machine that you developed. And second machines, you always do so much better because the NRE is now taken care of, right? You're not inventing anything anymore. You're just building another one of the same thing. So like over time, as more projects came from this company, we ended up doing just fine. But we had to, yeah, it was break even on that first project. We didn't make anything at all. In fact, maybe we even lost a little bit, but the long run, it was worth it. The real question is, how do you know, right? And there's just, I haven't found a way. You make your best educated guess and mitigate risk as best you can, but at the end of the day, you don't really know if it's going to be worth it.
Yep. Yeah. And I think not taking a throw at the dartboard is probably worse, right?
Yeah.
Then yeah, undercutting or breaking even. So
yeah. So you've been really into additive manufacturing for a long time. What are some of the cutting edge technologies related to additive manufacturing that you're really excited about, and maybe that not every engineer knows about because they're still newer?
yeah, so new technologies are coming out all the time now. And I think, yeah, taking a step back in timeline, when I did leave my corporate job, I got pretty heavy into the HP multi-jet fusion technology. So that was 2017, 2018, when that was first starting to be commercialized. Made friends with a partner, like one of the early on partners who had multiple machines. So the multi-jet fusion technology, because I had been kicking my material extrusion in my garage for multiple years, looking for something with more isotropic properties, something that I could take from prototype to potentially small run production was one of those things I'd been seeking. But yeah, so the HP multi-jet fusion technology, I started using that pretty early on, started doing some optimization with that. And I would say people have finally caught on now to this process, the SLS multi-jet fusion technology, powder-based polymer systems are kind of where everything is going to go. Like you have Bambu Labs and all the material extrusion kind of pushing up alongside it now. But Form Labs just released, the X1 version, basically the larger version of their fuse system. And I think everybody's noticing it extremely now that getting a system at lower cost now, so not spending $500,000 on a multi-jet fusion system, you can spend about a fifth of the cost almost now to get, a Formlabs X1 system. And so it's still pretty early on, but I think you're going to see more people get into this space. Now companies that probably were a better fit for low volume production can probably now afford that. And, the CapEx is all lower. But I would say, yeah, the polymer powder bed fusion space is continually growing. And you're getting a lot now with the Formlabs systems are kind of open architecture too. So you can actually play around with the formulations for like TPU to get different durometers. So I would say the Formlabs X1 system is one. If you haven't looked at it yet, if you haven't been getting phone calls, if you're on their list, I've been getting a whole bunch lately since they announced that. That's a system that I think, yeah, is going to make a big push to grow that space. And of course,
what is the difference? Sorry to interrupt. What is the difference between SLS and multi-jet fusion?
So this is a fun question because it's super confusing. They all use like similar names, and I could go into a whole thing about the ASTM correct way to say all the different additive manufacturing technologies. So polymer powder bed fusion. So you have powder bed fusion, it's its own category. So anything that involves a large bed with powder is in that category. You have multi-jet fusion, which is HP's own technology that they came up with. And then you have the more established like EOS systems is selective laser sintering. So you have those two, they're both polymer powder bed fusion. Multi-jet fusion is HP's basically their core inkjet technology, where they're able to disperse their agents into it actively as it's printing. It's actually using a thermal lamp in that case as the active energy source. And so it's carrying that layer by layer while laying down those agents. So that's HP's own technology, but it still fits the bill that it's polymer powder bed fusion. Then you go over to SLS, which is a laser-based system, right? So that's one laser, multi-laser, going in and applying that energy source in that case. And that's, the EOS system is the long-standing on that side, but there's new systems coming down on that side. And then you have Formlabs moving in. They are laser-based, but they're able to improve all the process parameters and all that to get that running faster now on the SLS side. So, and then you get a little bit of different properties. MJF is still a little bit better because they can become a little bit more isentropic because they have all their agents working. For SLS, you still get some different directional properties, because of how that laser is, and usually it's the Z direction versus the X and Y. Okay. So that's kind of an overview, but it's very confusing. Everybody uses their own fun acronym, and yeah, HP ruined it all when they put that in because there's other technologies that use similar acronyms, but they're in completely other categories than additive manufacturing. So,
well, I see you have your Bambu Lab printer right there next to you. How do you like that?
Yeah, so this is an X1C, and so it's already becoming obsolete. They're moving so fast. So looking at now getting, through my new product development lab, and I'll talk a little bit more about that, kind of the H2 series, larger build platform. But I would say if you don't have a Bambu Labs printer, you should get one. Like it's too easy to get one now. The prices are in a range where you can go down to a mini, even just to have one to do small level prototyping. I've talked with so many people just about the change over the last few years of the speed of being able to print multiple prototypes like in a day now with the speed that's in the Bambu Labs printers and the sensor suite and all that. So yeah, I'm a proponent. There's some things, that going on in the world economics where some people don't want to get Bambu Labs and the world politics for reasons that we could talk long lengths about. But the ability to have it in a prototyping sense is great. Like, I don't think you can probably speak to it too, just having some systems and working with students across some of the things I'm doing now. I would say probably 1 out of 10 engineering students I meet now through the university, they have a Bambu Labs, like some model. And it makes more and more sense to have one.
It's
So
kind of incredible how much technology they've packaged into their printers. I picked up a Bambu Lab H2D maybe 8 or 10 months ago.
yep,
And the thing is just bulletproof. I mean, it just works. And it's, like you said, it's pretty quick too. And they've got this great ecosystem where, I mean, I know how to use CAD, so mostly I model my own things and print them. But occasionally I'll just find something on their market that's already designed, and all I have to do is download it and print it out. They've got tons of different colors and materials. By the way, Bambu Lab is not a sponsor. They did not ask me to say any of this. This is just my own experience. It's just been a really great machine, and I think I paid like $2,200 for it or something like that. And it's a pretty large format. I mean, it's not giant, but it's, relative to most FDM printers out there, it's pretty good size, and it's quick, and it has this like automatic material system integrated into it, and it's web connected, and you can start prints remotely and check prints remotely, and it's just got all these cool bells and whistles for $2,200, which uh, even 5-10 years ago you couldn't get anything that good for that little.
yep, yeah. And I can, coming from that first generation of the MakerBot era and all these promises that there was going to be a MakerBot in every home, and then I started looking at connected printers too, because I wanted to be able to remote control, like turn on my printer when I wasn't there, get it started. And I had an Airwolf HDR printer, like as in one of my earlier on printers. And then all these promises, and then, oh man, you're spending more time just fiddling with the machine.
Yeah.
And then all we needed to wait was like almost a decade, right? And then we finally got
Yeah.
all the things that
Something
they talked
good.
about.
Yep.
Yeah, that they talked about originally. So
I remember having, I won't say the company, but it was a resin-based 3D printer long time ago, right? This is back when the prosumer grade resin 3D printers, SLA, had just come out. I don't know, it was probably 12 years ago, 14 years ago, something like that. And I probably spent as much time fixing the thing and fiddling with it as I did actually printing. It's like, I don't know, 30-40% of the time the print would fail, and then it's this goopy resin everywhere that is such a pain to deal with and clean up, and you have to have wipes all over. Anyway, that was painful back then. I almost gave up with 3D printing a little bit because it was just, I didn't want to troubleshoot these things. I just wanted them to work, and they weren't quite there yet.
yep. Yeah, and I think it's funny now, kind of going back and looking at what other printers could possibly get, and I've never justified getting my own SLA printer for the reason now we've moved to this point where you can get pretty fine detail, and if I really want to have something like top notch, I'll probably still send out for it and get it made, by somebody.
Yeah.
But it's just, it's so easy to have in an office, like no mess, like you said. And then, yeah, the resin systems, they've gotten better, like automation and all that, but they're just messy. They're harder to maintain. And yeah, I, I would say the shift over to most product development related folks doing work, like having the ability to have Bambu Labs printer, iterate quickly, and I think too I'm a fail early fast person, and you can do that. I've done it in the same day. Like you're making a couple of different versions. Like you have a meeting in the morning, and then like in the afternoon, like, oh, here's an iteration that I made within reason, depending on how big it is.
Right.
But being able to do that before, and having that quick learning, build, measure, learn feedback loop, it's just awesome to have now.
Yeah,
So,
and you can feel like I'm beating a dead horse here, but some of these Bambu Lab printers are literally just a few $100s, like $300
yep.
or something for a smaller
Yeah.
one, but still something that works really pretty well.
Yeah.
Well, tell us a little bit about what you're doing now. So you've got this adjunct professorship at Boise State University, and you've just helped them open a product development lab. What does that mean within a university context?
Yeah. So, yeah, I'm from Arizona originally. I moved here to Boise, Idaho about 5 years ago during COVID. Lots of fun shifting around with family things going on. I was doing my own business. I joined up with Athena 3D Manufacturing based out of Phoenix. and we had merged our services at that time. I had moved here because my wife's family is from here, Boise State University. I've visited before when I'd come visit, but I knew I wanted to be involved with the university after moving here. So through some things happening, I started working with senior design. So biomedical mechanical senior design was kind of that first entry into working with the university. So sponsoring a couple different projects, all focused kind of around different 3D printing technologies and 3D printing automation. And I think kind of leading up till now, been involved with product development, knew I wanted to work more with the university. And then over time, basically just through talking with different professors of, oh, you should offer, some type of a class as an elective to be able to get students more interested in additive manufacturing, maybe talk a little bit more about what the broader industry looks like. So that was that appointment kind of for adjunct professor. Universities, Boise State's no exception. They're always usually looking for people who are interested. They had a few other classes that were running, but nothing quite like an applications and additive manufacturing classes, which is what I baselined with for my first semester. And so, I completed that semester. It was a great learning experience from both ways, actually being in class, teaching a 3-credit elective, but really great. I love hands-on projects, having access to the university, and a couple of different spaces that they have. So they have the new product development lab. They have the engineering innovation studio kind of co-located within the College of Engineering. So lots of hands-on capability at the university for students to do projects that are incorporated into their curriculum. So that class, I wanted to incorporate that lab, having a whole fleet of Bambu Labs printers. So they have a bunch of P1S, Bambu Labs printers. I can't remember what the count is. I think they're in the 20, 25-ish, between their space in there, between P1Ss and some other models. But one of the projects that we did was a 1-pound combat robot, fully 3D printed. And so there's a league it's an ant-weight robot league where we actually followed rules. They talk about what 3D printing materials you can use. But a lot of it, I just wanted really quick iterative loops of printing parts, testing them, and what could be better than breaking them repeatedly by battling robots together and getting that feedback loop. So that was part of the class. So I like to have fun, in that context, bring that in. But then I also brought in just different industries. So I brought in medical device. So I brought in spinal implants. I brought in different applications engineers from HP, a few other companies, trying to get them exposure to what technologies are out there, what kind of career paths you can go into. The field, I call it a field. Everybody that's in it calls it an industry sometimes too, of additive manufacturing. And it was really great to get to see students kind of light up and see that how big it's become. And when you bring in titanium, orthopedic implants into class, and then you have an expert kind of come into as a guest lecturer, kind of talk about the applications where they're used, and then kind of give you a glimpse of what engineers do in those spaces. I wanted to make sure that was a big component of the class. So that kind of was the adjunct part of it. And then being at the university, doing kind of consulting and product development consulting again these last few years, I wanted to potentially even be more involved with the university. They've been looking to kind of revamp their new product development lab. So this is a group that's partnered with the university. So they're actually, they're part of Tech Help, which is the NIST Manufacturing Extension Partner Network, if you're familiar with it. Arizona Commerce Authority and others kind of in individual states have the manufacturing extension partnership kind of built in through the state funding. But this group basically helps local Idaho entrepreneurs, small manufacturing companies to develop their baseline products and help with design work and prototyping fabrication. And so they're a separate entity. They work with the university. And then the best part, though, is that we hire students into this new product development lab to work. So they're getting some mentorship, but they're also working on active projects with active clients. So it's kind of done through some shifts with some different funding situations after kind of the political landscape changed and some things happening. But they're revamping the lab up now to have more students, more incoming clients. And so I joined just this last month as the new product development lab manager. Pretty exciting. Definitely a lot to kind of look at for what we kind of want to do with the group. It kind of operates within Tech Help, which is part of Studio Blue. It's a program, and you have new product development lab, which is the design and create arm of that. But then there's also actually business and marketing help, which is the launch part of Studio Blue. So we have all these resources. An entrepreneur could come that, has a napkin sketch. They could come. It's reduced cost too. So we get some of the funding, like I mentioned, through NIST MEP. We can do reduced cost services for those entrepreneurs, help them design, create, and then potentially launch through some of the other services. So
very cool. And these students get an opportunity to work on real projects, which is absolutely the best way to learn engineering skills, actually doing the work.
Yep. Yeah. And it's, all entrepreneur clients that come in, they kind of know that students are kind of going to be working on their projects. So that's all kind of, given in the beginning. So there's a little space during the project to do a little bit of, that build, measure, learn cycle a little bit more. But we have all the access to great fabrication resources, and the students do get trained on all the equipment that is in the engineering innovation studio within the university. So they can actually go in, machine, laser cut, weld, have access to 3D printing resources, and then there's a whole bunch of other things in the lab too that they can help baseline do prototyping with. So
nice. Yeah. Fantastic.
Yeah.
Well, Stephen, I think we'll start to wrap this up here, but before we do, is there anything else that you want to hit on that we haven't had a chance to talk about yet?
Yeah, no, I think I appreciate you inviting me to come on. It was nice to kind of reminisce a little bit in the past and kind of the product development kind of path, through kind of building up through my own business. And I know we kind of connected through that. And it's just great to kind of see, where everybody lands, a whole decade later.
Yeah.
And I think, still doing product development, still in similar spaces. And I think some of the work you do through kind of developing the next generation is something now where I'm kind of at too. Like I love being in the spaces with students to help them grow, empower them, see them off into their careers, help them learn from my mistakes, and really just be a part of that and continually be a part of that through the rest of my career. So
very cool. Well, thank you for everything you're doing for engineering and for students. It means a lot to all of them and to the industry.
Yep. Yeah.
All right, Stephen, thank you for being with us today. How can people get in touch with you?
So you can contact me with the new product development lab through Tech Help. If you're looking for services, if you're located in Idaho, we even work with out of state also. But you can go to techhelp.org. You can fill out an interest form, and then we can evaluate to help you with your services. But then also, if you're in the Idaho area, we invite people to come to the new product development lab, check out the space, learn what the students are working on. It's a pretty open environment, and we'd love to be able to have people come as guests too, to kind of tour the space. So you can reach me. We'll probably put it in the show notes somewhere, and they always do this and give me my full last name in my email. So Steven Szymeczek at techhelp.org is my email. Love to get in touch. If you're in the Idaho area, I'd love to see how we can help. So
fantastic. All right. Well, Stephen, best of luck with the product development lab. Sounds like super fun and very exciting. And thanks again for being on the Being an Engineer podcast.
All right. Thanks so much, Aaron.
I'm Aaron Montcur, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services, visit us at teampipeline.us. To join a vibrant community of engineers online, visit thewave.engineer. Thank you for listening.